volunteer your scientific name that you found? Okay, yes. Okay, you spell for me. F-E-I-S-C-A-T. What else? And the U. And the S. Okay. Yes. Okay, are they right? Is it a cat? Is it a group of cats? Yes, okay. So I think what you will find as we share more scientific names, some of you may share 2 parts. Right? How many of you the scientific name you have comes in 2 parts? Quite a lot of you. If what you found comes in 2 parts, this is what it means. It means that that is the name of the species. And what do we mean by that? For example, for us, our 2-part scientific name, our species name is Homo sapiens. Actually, there are other species of humans. There was the Homo neanderthalis. Right? I'll give another example. There is Panthera tigris. And then there's Panthera leo. Different species altogether. Right? Sometimes, if for example what was just shared, just Felis catus. What this means, right, is they are going just one category above. They are ignoring all the different species. They are just looking at this group. Or in other words, one level above a species is genus. Okay, so there are many different species under Panthera. There's Leo, there's Tigris, so on and so forth. Okay, so if it's a 1-part, it tends to be like that. Right? More. Hey, anyone else would like to try? Okay, you spell it out for us, and then we all make a guess.
G-A-L-L-U-S,
Okay.
And then
And then?
same thing.
Oh, again. So Gallus.
Yes.
Is there a space?
Yeah, I think so.
So this is the scientific name, Gallus.
No, and then there's domesticus. I
Oh.
don't know, I just saw something.
So Gallus.
I have no idea if there's a space. Domesticus.
Okay.
It's a U.
Where?
The A is
Oh, Q. Okay, one day guess what you think this animal is. Or is it a plant? Okay, let's ask Kara questions. Can be a yes, no question. Kara, you.
No, it's not a plant.
Is it a fish?
No.
Is it a mammal? Is it a mammal?
No.
Oh,
Is it a bird?
Is it a rat?
it's a bird. Okay.
Bird.
It's a chicken. Yes.
It's a chicken.
It's in my backyard. That's why I named it.
Oh.
I get chickens, which is exactly why.
It's the scientific name of chicken.
Apparently.
Is there a particular species of chicken?
I don't know.
Okay, we're gonna type and search about Gallus. This one? This one? Okay, let's have a look. Oh, really? Wow. Okay, that's the scientific name of chicken. Wow, quite mouthful. Imagine you go to the supermarket and say, can you get me a pack of Gallus domesticus? Cannot even say it fast. Thank you. I didn't know that.
10 gallons in Mexico.
Kara is 10 Gallus domesticus. What a long name. Okay, very interesting. I learned something today. Anyone else would like to volunteer as a scientific name? You go. Okay, say again. Is it 2-part? Just one. Okay, so it's a group of different species. Okay, so what is it? H-E-L-I-A-N. Here. T-H-U-S. Like this? Neanderthals? Okay. Okay, this is a group of organisms. Okay, questions? Plant, okay, plant, not animal. Any more questions? Is it a flowering plant? Olivia has a question. also grounded in a lot of ancient languages also. Helios, you will say? Greek god of the sun. Perhaps it's not Greek god. Okay, next. Let's do two more. Yes. Okay, spell out for you ask, clearly loud and clear. A.
B U T I L O N space I N D I C U N.
Yes, you are correctly.
Is it Indian plant? I won't tell what it is. Oh my god.
Sorry, it's an N in that. Alright, one can guess what this is. Questions.
Monkey paw. Animal or plant?
Plant. Okay.
Aquatic? No.
Okay, a question. Is it a cash crop? Can make money out of it? No, no. Oh, you don't think so? Okay. Another question. Is it used for spices? Okay, not sure. Flower. Okay. Can you provide us a clue?
What color?
Do you see it in Singapore?
Okay, let's listen to the clue.
The flower is in yellow.
The flower is yellow. Daisy. Okay, let's search. Very long name. Abutilon. You ready? What do you think this is? Oh, what is this? Have you ever seen this flower before? No. Have you seen it before? No. Okay, but it was under M Parks. Okay, that means it's somewhere in Singapore. Let's keep our eyes open therefore when we go up to find, I don't even know how to pronounce it, Abutilon indicum. Okay, let's try to find that when we go up. Yes?
A-B-E-L.
Oh, you volunteered to accelerate, that's fast. Okay, we moved on. Last one for today. Okay, say again. Okay.
A-B-E-L.
A-B-E-L-E.
M-O-S-C-H-U-S E-S-C-U-L-E-N.
There's more?
Q-S.
Where?
Between the N and the U, there's a T.
Like that?
Yeah.
Sorry, where's the space? Where's the space?
Between, where you put it? Yeah.
Okay. Alright. Apple muscus is good. Yes.
That's more. Wait, M-O-E-C-H.
Only ask for one animal.
No, I mean it's still. It's not written on this book.
Okay, some more.
M-O-E-C-H. Oh my god. Yeah.
Is this part of this front part?
Ask him.
Is it? Been there?
He said it is.
This, okay, so it is this, and then this is the second part of the name. Okay, goodness. Okay, questions, please, questions. It's directed to your friend.
Plant.
Plant.
Is it a flowering plant?
Yeah.
Okay, it's a plant.
Is it
Okay.
a flowering plant?
Yeah, this is a flowering plant.
Okay, it's a flowering plant. Next.
What color?
Green.
Okay, a lot of plants green.
I don't know.
Yeah, we know this plant or not? Do we know this plant? It's very common. We eat it. We eat grass. Okay, last guesses. Is it grass? It's not grass. next time you want someone to buy a ladies finger, you say, hey, can you go to the supermarket, go to the vegetable outing, and can you buy another person? Yeah, I can't do that, that's way too long. Okay, thank you so much. Question for all of you. Why bother have scientific names when actually ladies finger quest done us quite well? What value might having scientific names bring to us as a community? Yes? Okay, we can use it to communicate about animal and plant species. Fair enough. Any other reasons why we might want to use scientific names? Yes?
Some of the things are related.
Oh, some of them are related, and you can tell from the name, is it, that they are related. Okay, fair enough. So the scientific name does give an additional layer of information like Panthera, Tigris, Panthera, Leo. We can tell that they are sort of related to a certain extent. Okay, it gives us information, allows us to communicate. Hey, don't cut his hair in front of us. It's not bad. Okay, anything else? Any other reasons why we might want to use scientific names? Okay, let's listen. Okay, share it. Okay, different parts of the world, we may call the plants or animals by different names. Just for lady's finger, I don't know what it's called in mother tongue. Do you know what it's called in mother tongue? Do you know what it's called in your mother tongue? Okay, I don't know what it's called. But actually, let's just look at eggplant. Right? You know another name for eggplant, some other people may call it brinjal. Right? Eggplant, brinjal, so many names. So, scientific names, what it does, I think the value of scientific names for communication gives additional information, and I think it helps bridge the gap between scientific communities around the world. Right? Regardless of where you are in the world, you speak this scientific name, if you are a scientist, you will know exactly what species you are talking about. But if I were to use my own language to describe what lady's finger is, we may have that gap. And I think that is where that's why we want to have a common language. Just like musical notes. Musical notes, regardless of where you go around the world, your musical notes, at least if you want to play classical instruments, they tend to be in that format. Okay? So, we have learned about how we classify in our previous lesson. We also learned how to create your own dichotomous key, and that is something that you are expected to be able to do when it comes to your homework and future quizzes. Today, we're going to move on to the next part of our chapter. Let's look at page 24, learning objective number 3. Have we done this before? Okay, on page 24, today I want to go through the 3 levels of biodiversity. Have we done this? Okay, let me tell you, 6. Okay, on page 34, I always want to refer you to page 34 because that's where all the learning objectives are. Okay, we have done number 1 and 2. Yeah? Okay, now let's go on to 3. Today we're going to share a little bit about the 3 levels of biodiversity. Okay, may I get you now to flip to the page where this can be found? Take my text. Okay, please flip to the page where you can find this. Page 42? Someone say 42? 43. Okay, we're going to learn about the 3 levels of biodiversity. As the name suggests, bio means things related to life. Diversity means how varied life can get. And actually, when we look at life at 3 different levels of diversity. And I would like you to refer to that table, which I think you can find inside your textbook too. Here. Okay. Today, at the very least, I hope you understand and be aware that there are 3 levels of biodiversity. What we are very familiar with, if I say that this place has high biodiversity, the first thing that comes to your mind is there are many animals, many plants. Right? That is what we are most familiar with. And what we are most familiar with is actually somewhere in the middle. Species diversity. This is what we are very familiar with. This is you thinking along the lines of, in this habitat, I find that there are trees. I find that there are birds. Okay, don't laugh. Okay, I find that there are, oh, okay, maybe there's a tiger.
It's a cat. It's a cat.
Okay? And then maybe that in this forest you also find some mice. Okay, thank you. And then there are mushrooms. Okay, so on and so forth. This is what we know of as diversity. I think very common to us. Every time we share in the news, we talk about biodiversity. Actually, we are very often talking about the many different living things, different species of living things present. Today, I'd like to introduce to you two more levels of biodiversity. Let's go and zoom in a little bit on a molecular level. On a molecular level, we have genetic diversity. And as the name suggests, I think you learned in primary school the word genetic code. Yeah, or genetic information in nucleus, you heard before, in cells. Okay? When we look at genetics, we are looking at your DNA. That's where we can be diverse too. For example, if I just go back one step, okay, let's just look at the mice. Let's say we have a lot of different mice. Sorry, not a lot of different mice. All of these are mice of the same species. They may look the same, but fundamentally in their DNA, there may be differences. For example, this mice DNA may have a slight difference over here. Maybe this mice has two differences over here, maybe one over here like that. Within a single species, within one species, there can be differences on the genetic level. Okay, that is diversity on a very small scale. Is that the diversity in our one species, Homo sapiens? Yes.
There are like different skin colors, different body types, different hair types, different hair colors.
Okay, different skin colors, different hair colors, different body types. Is there diversity among the human race, Homo sapiens? One species? Yes, there's diversity. We may be one species, but on a DNA level, there are slight differences. These slight differences can result in different skin color, hair color, sometimes different traits that you have. For example, I would like you to look at your wrist right now. Do you have this tendon? You see, I have this tendon when I do this.
Mine is extremely sad.
Do you have that? This goes down to your genetics. Because of differences in our genetics, some of us have this, some of us don't. But those that don't have, don't worry, you are still fully functional in your hand, okay?
I can't tell if this is or not.
Some scientists think that the ability to roll your tongue is also down to genetics. Can you roll your tongue?
Yeah, I can do this.
Who here can roll your tongue? Roll your tongue, not your tongue. Okay, your tongue. Can you roll your tongue? Some scientists think it's genetics. Some think it can be trained. Anyone here maybe should force yourself to train until you can roll your tongue? Okay, you have a case study there. So over those 6, one boy was showing me that other than rolling his tongue, he can make a clover leaf out of his tongue. Can you? Oh, okay, come turn around. Please show everyone your tongue. Look at that. You see that? Can you do that? Okay, let's spin around, of course. Only roll my tongue, then every day I look at the pictures, right, and how in the world you doing? Then I just keep practicing until I could. Other things that are genetic, your blood type. We may be all one species, Homo sapiens, but our blood types are slightly different. Whose blood type? Do you know your blood type? Whose blood type is O? Whose blood type is B? Can you remember? A. B. Maybe? Okay. So, differences, even though we are all human. The next level of diversity, we go one level higher. We look at ecosystem diversity. On the genetic diversity, we look at one species, different DNA. We look at species diversity, we look at one habitat with different species present in one habitat. When we look at ecosystem diversity, we are looking at a place that has many different habitats. If I say that a particular area has high ecosystem diversity, what I'm saying is that this area has many different habitats. It could have a pond nearby, a river nearby, maybe there's a forested area nearby. Maybe there's a grassland nearby. Many different habitats, and each habitat could have its own number of living things living in there. And one would expect, therefore, if you go to a place with many habitats, you will naturally have many species. And if you have many species, each species will have their own diversity down to the DNA level. So when we look at biodiversity, we look at diversity on different scales. We look at it on a DNA level. We look at it on a how many species level. We can also look at it on a how many habitats are there level. What your aim is if I were to provide you a comprehension passage, is whether you can tell me whether you see that this comprehension is describing a place that has high genetic diversity, high species diversity, or ecosystem diversity. Okay? I'd like to show you some examples. I'm going to show you a video, a very interesting case study of wolves in Yellowstone National Park. This is somewhere in the USA. Anyone here been to USA before? Okay. Anyone here been to Yellowstone National Park? You've been there before? How was it like? It's a nature reserve. Kind of. How about yourself? Lots of natural stuff there. Okay. Do you see wolves? No. Some wolves. You saw some wolves. Do you know that Yellowstone National Park didn't used to be what it looked like? It used to be quite a desolate place. A place without much life. It used to look very dead. But many years back, the USA decided to do something very interesting. It decided to introduce just one new species into this habitat. And they decided to introduce wolves. What do you think happened when they introduced wolves? Okay, the park flourished. Actually, that was the end state. It actually flourished. The park went from this to full of life. But isn't that curious? Wolves. You learn about carnivores, herbivores. Yeah, wolves are carnivores. Right? When we put a carnivore into a new habitat, how can it result in life flourishing? It's very odd. Yes, your theories?
They ate the wolves, the prey, they ate all of the animals that were technically close to the forest.
Okay, could it be that the wolves are end up eating the animals that were eating up all the plants? Could it be? Yes, you had a theory. After the wolves come in, is it? Possible? Could it be? I'm going to show you a video of what happened the moment we introduced wolves back into the ecosystem. And you see the trickle-down effects. It's very amazing what happened after. But first, let's watch a Grammarly ad. Okay. Okay, and of you all will start howling also. Don't know why. Don't know why. I like to think all of us are Homo sapiens, but every time I play this video, I start thinking some of you all went over.
It's the furry.
Okay, let's listen to the video.
Oh my god. No.
Yes, nice one.
The most exciting scientific finding of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And a classic example is what happened in the Yellowstone National Park of the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years, but the numbers of deer, because there was nothing to hunt, had built up in the Yellowstone Park, and despite efforts by humans to control them, they managed to reduce much of the vegetation there to almost nothing. They just grazed it away. But as soon as the wolves arrived, even though they were feeding on them, they started to have their most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately, those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. As soon as that happened, the birds started working. The number of songbirds and migratory birds started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed them too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. Wolves changed the behavior of the rivers. They began to meander less. There was less erosion. The channels narrowed. More pools formed. More riffle sections, which were great for wildlife habitat. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was a soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
It's quite amazing how when you add to species diversity, the impacts of it can affect other levels of diversity too. Right? Just by adding in this pack of wolves, it also influenced the presence of other animals and plants starting to reappear. And when other animals and plants start to reappear, also starts to shape the landscape. It starts to change the ecosystem and increase the diversity there too. Right? With more trees, it meant that the rivers will wind less. With more trees, it also meant that the rivers will also stay its course. So it's quite amazing how important it is to conserve our diversity at a species level. Because it influences at the end of the day what our ecosystem is going to be like, the many habitats. And also on the genetic level, how diverse the population is. As young people, it's important that you are aware of all this. Because at the very end of the day, there's a constant struggle the Singapore government has. We need more homes to house more of you. But at the same time, we only have this much land space. How do we coexist together to ensure that we and living things can all exist together without compromising on any of this? If not, Singapore will just be humans and our species diversity is just one. Human beings. That won't work out in the long run. Okay, if there's one word I'd like to introduce to all of you today, it's called keystone species. You can write this somewhere under the level of species diversity. Yes? Anything? Okay. So the word is keystone species. A keystone species is a species of that many other living things depend on. It happens to be the Yellowstone National Park. The wolves were the keystone species. Take them away, everything else collapses. Put them back, everything else comes back. A keystone species is very important. And that's the work of what many biologists are trying to do. They try to identify what in the world is this keystone species in each habitat. Because if we know what a keystone species is, we know what we should prioritize protecting so that everything else won't crumble apart. I'm just introducing this word to you so that you are a little bit more aware when you read the news. If someone will bring up keystone species, now you know how important that is. And you can relate back to the Yellowstone National Park wolves. They are that important. They are life-bringing, even though they take away life. Okay, so that's this part of today's lesson. If you look at learning objective number 3, what we require you to now know is the 3 levels of biodiversity. Okay? What's the 3 levels? Okay, genetic, species, as well as ecosystem diversity. The remaining part of our lessons, we will start to go into the more actionable. What can you do as an individual to conserve our species, our diversity? Next part of our lesson, we're going to start looking at the value of our biodiversity. What's the point of conserving all this? Is there a point? Should we just let it go to waste? Oh, still have 15 minutes. We can go a little bit. Before we look into the textbook, may I get everyone to close the textbooks? I'd like to show you that inherently, we do know the value of biodiversity. Yeah? So let's talk about biodiversity. I'd like you now, individually by yourselves, to think, what value might there be in conserving all of this? From the genetic, to the species, to the ecosystem. Why conserve our biodiversity, rich as it is on each level? What value might it bring to us? I'd like everyone to have a think. And then we will share, we will write down as many points on the whiteboard, and after we'll flip out the textbook, and I want to show you that actually we know the value of biodiversity. Okay, everyone, I'd like you to think. Joe, why are you moonwalking outside? Stay put. Okay, why? Why conserve our biodiversity? What value does a rich biodiversity have? To you, what? Yes, thank you. Sorry? Provide us with? Food. Food, okay. provide us with food. That's very important. The plants, the animals we eat. Anything else? Water. Okay, how does it provide us with water? Biodiversity. Animals and plants. Rivers. Okay, you saw just now how just by having trees we can keep our rivers running. Yeah. Okay. So water. Anything else? Yes. Oxygen. Where did you learn this from? Trees, right? You learned this in primary school, right? Oxygen coming from trees. There's a hand coming up here. No. Anything else? So many reasons why we might want to conserve. Yes.
Jobs.
Jobs. That's an interesting point. Could you elaborate? Yeah. Jobs.
Like there's fishers.
Sorry?
Like fishermen.
Like fishermen. Okay. Having biodiversity gives us jobs. Some occupations inherently depend on living things. Yes? Some people's livelihoods. How to spell? Livelihoods. Okay, some people who are indigenous and live in the forest, they may depend on the natural resources there. Okay? It sounds like some people may use it as a home. Okay, anything else? Yes? What? For study, for education. Okay, can you give me an example? Okay, scientists do research on animals and we stand to gain a lot when we learn about the biodiversity. Anything else? What other value might there be in having a diverse number of living things? Yes? Evolution, do you elaborate? Okay. Emily brought up the idea that species do go extinct. Those that remain may also change over time. I'm starting to gather also there's a new point you brought up here, that there are interactions between what is present currently. Yeah. Take away one and it may affect whatever is remaining also. Okay. Anything else? Biodiversity. What else might we want to conserve? What value might it bring to you? So that we may not be the only one left, right? Okay. How should I phrase this? So that we're not alone. Is it important that we're not alone? Why? Oh wow, okay. I didn't think so far, but that's a fair point. If it's just human species, I don't know where we're going to get our meat from. Never got away there. So what about you? Any thoughts? Yeah. What value might biodiversity have for us? What about to you? Keeps you alive and interesting. Okay, keeps Earth alive and interesting. That's interesting. Will you consider Earth alive? Will you consider Earth alive? No, but it has so much life that I find interesting you describe keeps Earth alive and interesting. Like a zoo, botanic gardens. Enjoy coming. Take a seat. So I'd like you to open your textbooks now. All of the various values we find in our biodiversity, we can categorize them into broader categories. Share with your friend. Here on page 44, we broadly categorize the value that biodiversity can bring into 5 broad categories. Number 1, economic. Kind of what your friends brought up. They provide jobs, they provide livelihood for people. Economic. You have heard the word economy, so it's to do with money, right? biodiversity does bring in the dough, the cash. Dough, the money. Dough is like bread. Okay. Second, ecological life support. It provides us with a lot of natural resources. Someone brought up oxygen earlier on. Without this biodiversity, we cannot live because we don't have these raw materials anymore. Take away plants, we don't have oxygen. Take away all the trees, right? Our river streams, we run dry. Sorry? How? Tell me how. When I wear a mask, then? Oh, you go to planet Mars, okay, and then? Okay, there's no oxygen there. Okay, tell me how do people produce oxygen? Okay, chemically speaking, you can. There are reactions that allow you to do so. You wanted to share? Oh, you are sharing that they wanted to induce oxygen on Mars, is it? Okay, we can do it. We know the chemistry behind it. But I had the impression you were saying that we can produce oxygen from ourselves.
I thought you were talking about oxygen from Mars.
Yeah, me too. Okay, so that's the second point, ecological life support. It's really essential for life. It's what keeps us alive. Let's look at the third point you can highlight. Recreational. What Joe brought up. Actually, it's interesting. When we have more life, Earth isn't as dull as it may seem. And a lot of the things we do depend on our biodiversity. How many of you like to go hiking? Imagine hiking in a barren desert land. Not much life there. Some of you may enjoy fishing. Some of you may enjoy photography of plants, animals. Some of you may like to draw plants, animals. Inherently, biodiversity can inspire all that. Fourth, cultural. In many ways, animals and plants have shaped our cultures. Some cultures worship certain animals as gods. A lot of cultures use different plants in different ways in our cuisines. You go to different cultures, you'll find that the same plant could be used differently in our cooking. Culture. Last but not least, scientific. I think brought up earlier on. At the end of the day, we also like to study the many different varieties of life on Earth. So why conserve biodiversity? There's actually a lot of value to it. Increasingly, this is also the buzzword. More and more people are really studying about biodiversity. But how is it relevant to Singapore? Let's flip to page 45. Okay. How are those 5 categories related to Singapore? I think today I'd like to give you one piece of homework. That piece of homework involves, okay, I would like you just to find one example out of these 5 categories of how it's related to Singapore. Understand? So for example, recreational. I'd like you to look up how has biodiversity enhanced the recreational aspect of Singapore. Okay. Why do this? Eventually, we'll provide you paragraphs to read, and in these paragraphs, we may give you these examples. Your task is to be able to tell me what categories you see there. So for example, I may provide a comprehension passage. In the comprehension passage, it could be a Straits Times article. In that Straits Times article, I may ask you, can you identify what's the value of conserving biodiversity? Then what you do in this comprehension passage is to extract out points in that way. So I'd like you for today, small homework, is just to research this a little bit. Choose one, and when we share, you'll learn a little bit more from everyone. You can see that we are coming to the end of our bio section. Because after we learn about why conserve biodiversity, we're going to go on to the next section, what's threatening our biodiversity. Next week onwards, we will start doing a little bit of physics. Ayo, the girl looks so distraught. We will start off first, okay, We'll start off first next week with measurements. Okay? We'll teach you the basics of measuring things. Okay, check, you took down the homework. Check. You took down the homework, right? Remind the class. Okay, listen. Next, I'm going to give you another set of worksheet. This worksheet, I would like to ask when you think you can complete it. So I'm going to pass it down first. No, some parts you haven't learned yet, but some parts you have. So I give it to you earlier. You can start earlier, you have less to do next time. Okay, let's go through this homework. What you need to achieve. Look at RE 2.1. Yes.
Thank you.
When you see the word RE, it stands for revision exercise. You will only get one revision exercise for every chapter that we come to an end of. This is RE 2.1 because it's chapter 2. Therefore, chapter 1 we did not have RE. Okay? Chapter 1 is Introduction to Science. Okay, so first page, you find that there are a few questions on biodiversity. You are expected to read an article by scanning the QR code, and also, or you can, you either read the article or you scan the QR code to watch a video. Up to you which one you want to do. Once done with that, you answer question 1 onwards. Okay. Next part of this homework, you flip to the back, and what do you see? What do you see? Yeah. We just rhyme each other. What do you see? You see a dichotomous key. Okay? We are going to do some practice. As I told you before, we expect 2 skills from you. Number 1, you can create your own dichotomous key, which is what we did last week. Or was it this week? Last week. Second, you are expected to be able to use a dichotomous key. And that is what the second part of the homework is for. In fact, if you find it quite easy, you can finish it in a few minutes. 1 to 2 minutes will be done already. Yeah? So you just have to identify each key from 1 all the way to 7. Okay? I do not have time to move on to the next section, so I shall not rush. I would like to give you some time now. If you like to, you can complete half of your RE, the dichotomous key, and you only have half more to go. Okay? Yes, thank you, Kara. Page 45, the research, as well as the RE. The page 45, I would like it done by tomorrow. But the RE, is it reasonable to expect it from you sometime next week? I'll just like to now ask, which day next week? Let's just negotiated for the maximum amount of time next week. Are you okay next Friday? Yeah. Fair? Hannah? Okay. So unless I'm in a rush for a certain timeline so that I have time to mark, I will usually consult you on when is a good time. Because I know that you have other homeworks on your plate and you may have other deadlines to meet. So next Friday, can? Check the note. Next Friday. Remind the class too on next Thursday for the last minute workers. For those that are free, you can start with your RE, the second part. I think you will need a few minutes. Yes. Good practice. As I'm looking around, every time new homework comes up, you use your diary. If you do not use your diary, please have some other means to note down. As you grow older, more and more homework will come. Okay? So I take that back. Not more and more homework. There may be more things in life you need to prioritize, more responsibilities. Yes? Search what these terms mean. Then maybe you will understand what after this? Okay. Okay, we don't need to say goodbye. You just continue on with your quiet work. Erase the board, and then the next one will be mother tongue. You need to go for mother tongue.